How are you, doctor?
Alhamdulillah, I'm fine. Jazakumullah khairan, sir.
Barakallahu fi.
I mean, so actually, I have a data set that I've practiced with on Wika. So my question is more practical now.
Okay.
Yeah. So we've tried to simulate the data using the different algorithms. It's a regression problem. So we want to determine the compressive strength of concrete.
Okay.
Yeah. Yes. So, and we've been able to identify the best algorithm. We have done the hyperparameter optimization tuning. We've checked for some feature engineering and the stuff like that. So, and we've determined the performance measures using the correlation coefficient, or even when we square the R, that means determinant coefficient of determination, and the errors. So particularly we focus on RMSE. So, but my question is that now we have determined the best algorithm. Earlier today, you talk of deployment. So how are we going to deploy it in Wika? So because I try to say, if we get a different data set now, maybe somebody else gave me laboratory results from their labs. They don't have that compressive strength. How can I do it in my Wika? So somebody want to give me now as a consultant.
Okay.
Yes.
Okay.
So that's my question.
Thank you very much, doctor. So, and I'm really very happy that you have gone so far in that respect. So keep it up. Wishing you all the best. That's very, very interesting that people are taking it up. And then, yeah, like we mentioned, there are so many application areas we can always think in our own area. So Dr. Abidin is an, if I'm not mistaken, civil engineer by profession. So I think working in this kind of compressive strength of material is very, very important thing, as he has explained. So and often difficult to predict or to estimate. You have to stay a lot of time, in longer time in the laboratory to be able to do that. Now with machine learning, you can easily just estimate parameters or attributes that are very easy to estimate, and then you can use them to make prediction. Now, having successfully built the model, doctor, that is good. If you now have a new deployment, if the company wants it, there are two ways they want to deploy. You want to deploy the one you have built now, then you go back to your Wika. The model you build, you can always save your model in Wika. You can save it later on. And if you don't even save the model,
even I have issue with that as well.
Okay.
Trying to save, when I right click the model build to save, the option of save is there. But when I save, I couldn't open it. I'm not sure, maybe something is wrong that I've not been able to do properly.
It's supposed to save, maybe there's some issues there. But however, that's the problem. Those are minor issues. So the option is the person can try to, when you want to build the model, there are different ways of partitioning the data set, if you remember.
Yes, we actually tried many of those ones. We were able to see that the best one is actually on the percentage split of 85%.
Excellent.
So we try cross-validation 10-fold, 5-fold, then we try all the other percentages as well. But we got the optimum result at 85%.
That's good. 85% is still more. So, but I would recommend not to go beyond that. So yeah, usually people go to 90, it means the percentage of testing is going to be low, but 85 is still fine. 85 is good.
Well, we have 1,030 data sets.
Okay. That's very good and very rare to have such huge data. So that is huge in material science. We call it huge data sample in material science because often we have 18 samples, 22 samples. That's what we usually use. So that's very interesting that you have such a large number of data samples. However, on the issue of when you now have, on top of that, cross-validation or divided into 85-15, go up a little bit on the Wika, you will see supply. You see supply data.
Yes.
Yeah. So this is the option. This is the option you are going to use for new data coming from your client now.
When I use that, sir, and the data set in the prediction values are not there, That means the compressive strength values. So it did not run. But when I put values for the compressive strength, it ran.
That's the value output. Am I right?
Yes, I mean the output. Yes, when I put the output there, I was able to get the values. I mean the correlation coefficients and the other error values there. But if I did not put that values there, the value for the compressive strength, and I just left the column empty, which is what I think should be what I need to get from my people.
Yeah,
Yes, it
it's okay.
did not run on. It did not run on water.
I got that. That's okay. See, what is happening is this, because when you give your data, whenever you give your data to the weaker, you always supply attribute. It counts the number of attributes as so. Are you with me?
Yes.
Yeah, it counts the number of attributes to be maybe 9, including the outputs. So if you put it empty, there's going to be an error. You get the point now? Yeah.
Okay. But I put the title there, strength.
Yeah, the start is there, but the values are empty. Am I right?
Yes, the values
so
are
don't
empty.
worry. For now, this is one of the price you have to pay for using the free software. You get the point now, okay?
Okay.
Yeah, in the idea system that can be deployable, then the client has to be ready to pay money to have to get the source code and get some other things actually done, which we can discuss this one later on. However, what you can do is when you have such a thing, I'm happy also that you are able to try that one out. When you get that, just create, what we are looking for is the output. Create some fictitious strength and put it in that column, okay?
Okay.
Just don't worry about it. It doesn't use it. It only uses it to calculate the result of output. It has to give you some output, that this is the accuracy, this is the this. That's why you need that one. Just create, once your client supply you with data, the output, create some fictitious random number. Put it there.
Okay.
Upload your value. Once it predicts it, just show the result and extract your result. And you can see that, this is reasonable. You get the point now?
Yes.
Yeah.
Okay.
So this is how you solve the problem. You not get error. Create some fictitious value there.
Values. So it is because I'm using a free software. So that's why it's expecting me to put some initial value.
Yeah. So it's not meant to be deployed for company. Company has to pay money for programmers to come and do some things for them. You get the point.
So that means you programmer, you still want to take money from me.
Yeah. So this is, but for now, somebody can use it. Like I said, just create a kind of fictitious samples. Even some of the what do you call it? Some of the open source software, and then when it comes to deployment for companies, then companies have to take responsibility. You get the point? The open sources, they are for education purpose, learning, and others. But when it comes to companies, then they are expected to, for example, Java is very, very popular, and also free. But if an organization wants to use it and get support, then they have to pay for it. You get the point now, Doctor?
Yes, I got it from you.
This is how it works. Nothing is really free. The free one is just meant to make it popular. But anyone who wants to use it for commercial purpose has to be responsible in that respect. So I hope that clarifies. But this is how you can handle the case.
Yeah. So my question is that even if I want to proceed to publications now, so can I still use the one where I actually formulate the initial values by myself and include that as one of the steps I take?
No, what you have to do is this. If you get data from the industry, you see, the publication is interested in your training set and testing set. They are not interested in the deployment set.
Deployment test, okay.
Because the deployment set doesn't have known value you can use to validate. We don't know the value. Am I right?
Yes.
We don't know the value. But
but at least if it's giving me a reasonable value, I will know, because I know from practice the range of values that I'm expecting.
Exactly. If you like, you can include it, but it's really not needed. Usually, sometimes we get training testing data from company. Then later, the company also has another data, which they know the output, but they didn't give us during the process of building the model. After
Yes.
we take it to them, they now give you. They say we know the value. Can you run your model and show us the result? We will compare your result with what we have. You get the point now. They want to
Yes,
use
I got
that
it.
to further increase their
Check.
confidence in the modeling. Because what
Model,
you are
yes.
telling them is that you can predict compressive strength with high precision. And you want them to rely on what you are predicting to construct their overhead pass and the like, which are issue of secure safety. You get the point now. So
Yes.
in that case, they want to test your capability of your machine learning algorithm as the case. I hope that clarified, Doctor.
Yeah, it's clarified. Thank you very
Barakallah
much.
fi again.
Um,
So I wish you success on that, and I hope you get
okay,
acceptance.
yeah, but again, now there's this question of how do I save my model? I'm trying to do that. I
Uh,
run a model now. If I right click on Wika,
yeah.
so I have the option of load,
Load
view,
save model. Yeah.
save model. But when I click save model, I can save, but when I want to open it, it's not opening. I don't know. Maybe I'm choosing the wrong option to save. I don't,
You have to make sure you save it proper. It should save.
yes,
Uh,
I click
yeah.
save
If
now.
you
I'm doing
cannot
that
save
now.
it and you
Yes.
cannot open it, maybe make sure you save it in the right. Don't save it on C. If you have another, if you partition your machine, C is considered security stuff. Sometimes when you want to save, the saving is not completed. So when you want to load, it's going to be corrupted. Okay. So there's if it is organization laptop, they put some restriction on it. You cannot save on in some part of the system. You have to check this out. Save in your document, local machine, not inside the C. Hopefully you should be
Okay.
able to get it through. Yeah. Otherwise, you can have a small Zoom section and then we can be able to clarify for you how you can do that. But you should be able to save your model. Yeah.
Okay. Yeah. Thank you very much. So if you are free, you can actually do that after the class, sir.
Barakallahu feek, eh?
Yes, sir.
So I believe Dr. Cyril and you.
Yes, Assalamu alaikum, doctor.
Alaikum salam. How are you?
I'm fine, Prof.
Thank you very much.
Yeah, thank you for the class again today.
You're welcome.
Yes. So my question is actually concerning the imbalanced data you
Okay.
discussed. So you said it's better to do the pre-processing. That is, maybe if we want to use over sampling technique, we use it, we break the data, then we use it on the testing data, right? Because when we want to actually deploy the model we have built, it's going to be on real data, which perhaps might end up being imbalanced too.
Yes.
So now I'm now thinking of, is there a procedure where if somebody decides to maybe perform the oversampling technique on the entire data, okay? He builds his model.
Yeah.
Now, that same procedure he used in performing the oversampling on that data he used to train the model.
Okay.
He automates that process so that when the data, when he wants to deploy a real world data and it is imbalanced, that same process is performed on that real world data.
Okay.
Because now why I thought like this is when we pre-process, okay, or we use oversampling technique on the training set, okay, to me, I feel the data somehow has been adjusted.
Yeah.
So during that training, the model is understanding this adjusted data.
Yeah.
So I believe in majority of cases, it may not perform well when it sees an imbalanced data. Maybe in some cases it may, but I want to believe that in larger percentage of time, it's not going to, because it was trained on something different. So I'm thinking of why not carry the same probably automate the process for which we process that data for the training set, so that when the model sees a real world data that is imbalanced, it does that automatically, and then it gives us the output.
Yeah, I get you.
So
I get your point, Dr. Siri. Thank you very much. And for the technicality brought in, yeah. You see, it's a matter of best practice. You get the point now, okay? Often people used to do this. You know, during the deployment, when you have new samples, those samples are not going to be used for training anymore. They're not supposed to be used for training. So the idea of automating what we have done for the training testing before actually does not even arise, because now we are not going to do training anymore. We just bring the data. Let's say we are deploying in real life. We want a system that can in real life identify somebody, this is a threat, this is not a threat. Or identify a product that is coming from the factory production system. This is correct, there's an error. This one is not correct, this one is okay. Like quality check. So in real time, there will be many products that will be okay in the quality. Few of them will not be correct. This is why in most real life situation, imbalanced data is real. So that's why once we train the model on the randomly oversample model, and then we kept it, the one we kept out for testing is also not balanced. If it work on that one, then when you take it to factory or for deployment, it will work on the new cases that are also not balanced in the real world. However, if you train using the balanced data, which is artificial balancing now, and you test it on artificially balanced data, it may give you 100%. You have seen that sometimes. However, when it comes to real life, because real life does not give room for you to balance. You get the point. Somebody is coming now, you may be able to identify him. There's no room that you collect the data. This is real-time solution. I hope you are following me, Mr. Dr. Cyril.
Yes.
Yeah. So it's a real-time solution that we have trained and tested the system. It's working. We have tested it several times. It's working. Now we are deploying it. Mistake by the company is costly to them. It can kick them out of market. So they can't afford to make mistake. So this is why if we have trained it and tested it, the training set is randomly increased or for balancing. Yeah, we know we have changed them to maybe data that is fake, a little bit of this. This is why when we are testing it, we have to test on correct data. That's why we say the testing that should be reserved. If it's able to pass the test by not making mistake that is not acceptable, that means even though we have randomized our data and created fake data, it is working for us. Then we can deploy it. If it doesn't work, there's a problem. So, but having the testing and training set to be both fake data means we cannot even think of deployment, because the real life data is not going to be like that. I hope that clarifies.
Yeah, that's fine now. That's fine.
Thank you very much for that. So shows you closely follow the explanation and it's clear.
Yes,
thank you very much.
Yes, sir. Thank you, sir.
Thank you. Then I think that's all we have. Oh, I think there's one questioner before we call it a day.
Assalamu alaikum.
Alaikum salam. Sorry, I'm trying to see. Okay, Mr. Abbas Abdullah.
Yes, thank you so much, Professor, for your wonderful presentation. So actually, my question is also in line with Dr. Cyril's question.
Okay.
So regarding the random oversampling that you just made explanation. For example, now if we want to do that in a data set, and for example, we have data set that we have to normalize the data sets. So is it that, are you going to do the random oversampling into the data set before we normalize the whole data set, or after we normalize the whole data set? And if, for instance, my second question is, if we normalize all the data sets before applying the random oversampling process, type. So if we have a new data set that is coming, for example, from the hospital or from the clinic, so that means each and every time we have to normalize the data sets before we apply the random oversampling. I don't know if you got me.
I got your point. Yeah, I got your point. Yeah,
Yes,
That's it's clear.
yes. So each and every time, isn't that we have to normalize the data sets before we apply the random oversampling
Thank you
into
very
it?
much. Yeah, this is one of the reasons actually why I told you, I said several of the procedure we do in the pre-processing stage. So we should only do what is compulsory. You see, everything that is optional, based on the principle of let the data speak, we shouldn't do it because, yeah, as you just noticed, it creates fake data. So like normalization is not compulsory. So run your experiment, your original data set as it came to you from the industry or from anywhere. It is when we have tried to do hyperparameter optimization, feature selection, and host of others, and we are not able to get what we need, then normalization will now come in. And we are now convincing that, it seems normalization might give us better result because we notice that the unit of each of the attributes are different. Some are in kilometers, some are in kilograms, some are in gram. So in that case, and we cannot be doing conversion for each of the attributes, the best way to solve the problem is to just normalize them. So let them be between zeros and one or -1 and +1. So all data sampling irrespective of the value, we fall in line. So we do this when there's necessity for it. It's always good to let the original data remain. Because the moment you normalize, there are two main normalization here. Some people will normalize the target if it is not classification, for example, if it is real number, regression. If you normalize regression, it means the value you are predicting is not the actual value in the real world. So you have to denormalize your result to be able to calculate the actual result you are getting. So in which case also, when any data comes from the industry, yes, you have to normalize it and then denormalize. For the attribute, the target only. But for the attribute, once you normalize, you don't need to denormalize because we don't need them. Once they do the prediction, we forget about them. But for the output, we take it further. So if you don't denormalize, imagine values that are in millions, you're only reporting it as 0 point something. It will not make any meaning. And the root mean square error also will be smaller. That could also be confusing. So we have seen people who normalize the output and they were getting root mean square error of 0.00 and they were celebrating until people say, okay, where is the output? All the outputs were like 0.1, 0.11, 0.10. Then that's okay. This is not the value we gave to you. Where is our value? Then he now realized that, we normalize it. Though he has to normalize. By the time he normalized it, the root mean square errors went up. You see, this is why whatever procedure we have taken, we have to take note of it to make sure that the result we are displaying is not fake. Because in corporate world, they might not take it lightly. They might even think that the person did it deliberately. So that is why in the principle of let the data speak, let us use our normal data as much as possible. It is when things goes wrong, then we can then do normalization, we can do missing value treatment. It's very important. But sometimes another question also is when you want to do missing value treatment, one of the popular way of treating it is to replace with mean value. Then somebody says, okay, should we treat outlier first or after missing value treatment? Because outlier, let's say you have 1,000 mistaken number in the midst of 0.1, 0.2, when you add them together and find the average is going to be too huge. It means outlier will affect the missing value you are going to input it. So this is why all these pre-processing methods, they should be kept optional and come back to use them when it becomes necessary that it can improve the predictive power of your model. And for normalization, yeah, it's very sensitive. For me, my advice is I only encourage students to normalize the attributes, but don't normalize the output. But in some cases, some problems are very tough. If you don't normalize the output, it cannot predict well. Then you might have to normalize the output. But remember, when you normalize the output, you have to denormalize it. Return it back after the prediction to the original value. So to make sure that you are getting the correct result. I hope that clarifies, Mr. Adam.
Yes, thank you so much.
Barakallah. Thank you very much for that also. So, yeah. Okay, somebody's asking. Yes. So, said before we go, Prof, you said we should remind you on the crop prediction modeling building in which we propose using the Google form from the input of the group. Yeah. Thank you very much. So, Mr. Abbas Abdullah. Yeah, last time, we said we are going to discuss crop prediction, so looking at the importance of agriculture to the economy of the whole world, to the survival of humanity, actually. So how can we use machine learning in crop production? One of our members here actually requested for what are the possible application of machine learning in crop production. And then a suggestion came last time that, okay, we're going to have a kind of Google form, which I think Mr. Abbas Abdullah has volunteered to prepare. So once you prepare that, we share it in our platform. If you have any feedback on that, so hopefully soon we are going to start discussion on application of machine learning towards increasing crop production. What can we do? What are the areas of interest that we can explore so that together we can all see how we can be able to increase the capability of putting foods on the table of humanity. So thank you very much for reminding me about that. So so the form is ready. We will definitely share it with people so that as soon as we get things ready, we will start the presentation on crop production or utilization of machine learning in crop production. So everybody will see where and how we can be. So everybody's supposed to be a farmer in his own small way. Even at the backyard, at your backyard, you should be able to farm what you are going to eat. Basic vegetables should be available for you. We were taught that this thing generates oxygen. The byproduct of photosynthesis is oxygen, which we need enough. We need so much in our houses. So everybody should have plants around him. Instead of just planting flowers, you plant food that can serve both purpose of generating oxygen and at the same time also producing something you can also use in a hopefully better and then healthy form. So thank you very much for that. So attend to my so thank you very much. So wish you all the best. So any other question and answer, we can always follow up as the case may be. Thank you very much. If you forward any message, you don't get response within some time, please feel free to re-forward them. Sometime we miss it. So always try our best to respond to some of our requests within the possible time availability. So once again, thank you very much for attending, and then hopefully you also share the message to other people so that they can benefit. Do also remember to subscribe to the channel so that you can always get the video once we upload it, and also benefit others by also sharing with them. Thank you.